Okay, before we start this lesson, I'm going to ask that you sketch exactly what I have sketched here on that graph that you have at the top of your page. It's important that you label this point here or this marker here to be your 1 and this one as well to show that we're counting by ones. So pause the video and recreate this picture. Remember, these points are pretty important. Where the function intersects at a few of these points is something you're going to want to be consistent about. Okay, so now that you've done that, we're going to answer a few questions that are going to lead us into dealing with average rate of change. Okay, so we're going to start with just a very simple question here. What is happening to the value of f of x over time? So this is kind of a broad question, and that's because it depends on what we consider to be over time. What is the interval we're looking at? I'm going to zoom in here really close for a second. If we just zoom in to this part of the function, right, even maybe just this part, we would say that over time, our function is decreasing. In fact, we would say that it's decreasing from a value of 1, 2, 3, 4, from 4 all the way to -2. And an important part of this is that it is decreasing from 4 to -2, but how long does it take? Well, it takes 1, 2, 3 units of time, right? If we're going to call x-axis our time axis. So we might say that it's decreasing by 6, 1, 2, 3, 4, 5, 6, in 3 units of time. So what would that rate of change be? Well, we could say that it's decreasing, so a -6 over 3 units of time, and -6 divided by 3 is -2. So we could say on average, we're losing a height of 2, we're losing a height of 2 every 1 unit of time. And it seems like that's the case. We lose 2 every 1. We lose 2 every 1. So this question is pretty broad because if I zoom in on a different segment of time, like maybe I even just expand it to that window, and I take a look at what's happening to my function over this whole interval, well, that change is still -6, right? I've gone down 1, 2, 3, 4, 5, 6. The value of my function is still 6 beneath where it used to be. But this time, instead of it being just 1, 2, 3 units of time, it's actually 5 units of time. So in this case, we would say, what's happening to our function over time? Well, it decreased by 6, but over 5 units of time. So that might be a rate of change of -6 over 5 rather than -6 over just 3. So it matters what our window is that we're looking at. So this question is pretty broad, so maybe they're saying, what's happening to this function over all of the time that it exists for? So I'll make our window the whole function. So then we'll say, well, let's say we started here and ended here. What is the change that happens over that amount of time? And I'm just going to sketch in a little line to show what we're looking at here. From the beginning point, which our beginning point looks like it's the point -7, 4, to the end point, which looks like it's the point 8, 0, what is happening to the value of f of x? Well, it looks like the value decreased. It is decreasing. And I would say it's decreasing by 4, right? Because if it starts having a value of 4, and at the end of time, as far as we're concerned here, we have a value of 0, well, then it's decreased by 4. So that's what it did over time. Now, we're going to start to talk about slope in a minute. But you can see that it lost a height of 4, and how long did it take? Well, it went all the way from -7 to +8. So that's a distance of 15 because we go up 15 units over that amount of time. So I would say that the change is -4 over 15 because that's how long it took to decrease by 4. So we're going to continue exploring this a little bit. And this is something we talked about. Would your answer change if the domain of our assessment were more specific? Yeah, the domain is referring to the x values, right? So just like we talked about, if I only care about this domain from -7 to -4, well, then my change is -6, Because if I'm only looking at this window, it decreased by 6. If I'm looking at this window, it only decreased by 1 because it has a height of 4 here, but as we move over to this point, it has a height of 3. So if this were my assessment, then I would say that the change is only -1. It only goes down 1 unit. And I could keep changing it. Maybe I make this my window. In this case, I would say that it actually gained height. Our function increased over time because it used to be at 4, and now it's at 8. So I would say that it increased by 4 units. So yes, the domain that we choose matters because in this particular case, this function is not constant. So because our function isn't constant, the window we choose to look at, or the domain that we choose to evaluate our function over, controls what our change is going to be because this function isn't constant. And so it depends where I begin and where I end when I'm going to determine that. So over which interval is f of x increasing the fastest? One of the key words here is increasing. So I want to find only the places where our function is actually increasing. Here it's decreasing, so I don't want to use that. Here it's not doing anything at all, not increasing or decreasing. But our function is increasing here. It stops increasing, it looks like, when x is 2. Then it starts decreasing again. So anything along here is an option for us. And our function is also increasing here, so that's an option as well. So we've got to figure out where is this function increasing the fastest. So at this point, it's probably a good time to give ourselves a formula that we can use to figure out the rate of increase. And then we've been doing it logically, but now we're just going to take that logic and put it into a formula. So here's our average rate of change formula. F of b minus f of a, all divided by b minus a. And we've been doing this logically anyway, so let's see how this works. Let's pick any 2 points to start with. Let's say we're going to test the rate of change here in this interval. It looks like we begin at the point 6, -3. That's that point, 6, -3. Okay, and we end at the point 8, 0. So here's how we're going to use this. If I'm trying to figure out what my average rate of change is from this point to this point, then I'm trying to find the average rate of change over the interval from when x is 6 to when x is 8. So the interval that I'm testing here is from 6 to 8. What that does is it makes 6 my a value and 6 my b value, or an 8 my b value, and that's what I'm going to plug into here. So I'm going to calculate f of b, and then I'm going to subtract from that f of a, and I'm going to divide that whole expression by b minus a. So how does that work? Well, f of 8 is something we got to determine now, so I'm going to figure out what is the value of my function at 8. At 8, my function has a value of 0. So f of 8 is 0 minus. At 6, my function has a value of -3, so that means that f of 6 is -3, all divided by 8 minus 6, which is 2. All right, we're just going to finish this here. That gives us 3 over 2. So what we can say is our function is increasing at a rate of 3/2 over this interval. And logically, that's what we would have done anyway. We would have said, well, how high does the function go? It starts at -3 and it goes up to 0. So that's a change of 3. And how long did it take? 2 units. Went up 3 units and it took 2 units. So this is our rate of change. And what we want to do is see if we can find a faster rate of change somewhere else here. It looks like our function is increasing really, really quickly over this interval. So what I could do is I could test the average rate of change from this point to this point. All right, and let's see what we would end up with. The first point is the point -2, -2, and the second point is the point 2, 8. Yep, 2, 8. Okay, so what we're testing here is we're testing the average rate of change of our function over the interval from -2 to 2, because those are the x values that we're going to test. So -2 is my a, 2 is my b, and I'm going to use my formula now. f of 2 minus f of negative 2 all over 2 minus negative 2. Well, what is f of 2? Got to evaluate this part first. I'm going to go to my graph. It looks like at 2, my function has a value of 8. So f of 2 is 8. What's f of negative 2? At negative 2, my function has a value of negative 2. So f of negative 2 is negative 2. And I'm going to divide that by 4 because 2 minus negative 2 is 4. Simplify the numerator and I get 10. So this reduces to 5 halves. So that has an average rate of change of 5 halves, which obviously is a greater rate of change than 3 halves, right? So far, this interval is in the lead. So what I'd like you to do before we come in is test 2 more intervals. We tested from 6 to 8, and we tested from negative 2 to 2. So before you come in tomorrow, I'd like you to test this interval that I'm going to highlight in green. So from negative 2 to 4, I'd like you to test that interval's rate of change, and I'd like you to test this interval's rate of change from negative 2 to negative 1. So I'll write those over here on the side. The 2 intervals that I'd like you to test are this interval from negative 2 to 4 and from negative 2 to negative 1. And what you're going to do is you're going to use this average rate of change formula and the picture of the graph and give me a number that represents the average rate of change. So when we come in, what we're going to do is we're going to evaluate the results that we got and figure out which of them represents the fastest rate of increase, and we'll pick up from there.